welcome back. I think we're live now. Yeah, I need to learn how to use these things properly. Still every time I have, all right. Welcome back. Sorry, I'm still struggling every time to completely figure out how to get OBS to connect to YouTube. Make sure that YouTube is receiving it, and then making sure that I've clicked all of the different buttons that are required for this to be live. But then I actually went ahead and opened YouTube on a different browser just to check that we are live. But I'm actually just gonna because otherwise I first thought we were live and we were not, and then now I think we really are live. Anyway, okay, I've tried to make the screen bigger. I've tried to make the screen bigger, and I've tried to make the fonts bigger for everyone. And yeah, so there is a little bit of a delay. So that's something to keep in mind. So I do keep an eye on the chat, but just because of how everything fits together, I will see the messages, a little bit after you post them, but mostly the delay is that, between me saying something and being streamed, there's I think, something to like 20 seconds to a minute delay there. This is also why some messages last week at the very end of the stream, I actually didn't see them before I logged off, or I only saw them when we were no longer live, and this is also why then I couldn't answer those questions in the stream. I tried to answer them afterwards in the emails, but yeah, this is also try to explain how everything, I'm also still trying to figure out how everything works. But so nonetheless, I have the YouTube chat there, I have the Discord chat, and let's get back to it. Okay, so alright, so sorry, that's none of that really matters. Okay, so this is where we were. Let's do a recap. This is where we were. We had left some notes. We had left some notes where, start internal library, and because we had done this exploration and then we had done this heat map, and we're going to do then this is a bit to just do this again. And partly while doing the recap, I actually noticed that I had messed this up, because in cleaning up at the very end of the stream, I had deleted one very important line, namely was actually not filtering by the habitat. Okay, and so this is what we got, right? We got this matrix where you can clearly see these block structures. So there are these co-occurrence blocks that show up. Okay, so today the first thing we're gonna do is we're gonna do what we said we were gonna do last week, which is convert some of this code into kind of an internal library. So I'm literally going to start with load data.py, and let's just copy everything over and work by removing the things we do not need. Okay, this is a bit too big, the fonts. I'm trying to keep a good balance between. I know also with the streaming sometimes there's some artifacts that make it a little bit harder to read. So okay, so this doesn't matter. This was we want to write a function load data. Yeah, something like this. Something like this seems kind of okay. Yeah, this seems okay. Let's see this. Yeah. So as I said before, I find that GitHub Copilot, which is what I'm using here, is very, very good at this exact situation, which is you have a piece of code that I had there, and I just wanted to adapt it. So the logic, the logic was already all there. I just needed to switch it around, and so in this case, it really did complete it quite quickly. Let me just check that all of these. Yeah. So here I am using the star to find all of the instances of this. So that means that PL is being used, NP is not being used, LCMA or LZMA is being used. And I am going to move the imports there and add a little bit of a yeah, that's correct. Yeah, that's correct. Okay, that is pretty good. I'm actually going to do something slightly different. No, let's keep that. Yeah, let's keep this. Okay. Okay, let's just try it now. Yeah, this is pretty much expected. Actually incorrect. I don't know. Let's do dogs. I like dogs. And here in this case, I know because this dog data is from a paper we had many years ago, and we still work on it a lot. So I know there's 129 samples there. To be sure. Okay. Okay. Alright, so here now. Okay, so now we've extracted this small piece of code And this is all we need. Okay, now we go back to the okay, this is a bit okay, let's we need to be careful with the paths here. Let's see. I'm gonna do it the lazy way, which is I am going to create a symlink so that independently of whether we are at the top level directory for the project or we are inside the source directory, there's always the paths are always the same. Okay, and now need this. Now all of this stuff at the beginning simplifies to okay. Know what's going on. What's going? Oh, it's just it's still computing. Oh, there. Yeah. Okay. So, all right. So, So far we have achieved nothing in the sense that the code has not changed. It's still doing exactly the same as before. Yes. Okay. So there's a question. So inserts in the context of the code you're writing means the DNA between the Illumina adapter sequence. Yes. Well, yes. Unfortunately, as with many things, the people actually used at least two different meanings that I know of. So one is indeed the. So here, what we do mean is like. This is a single read, a single DNA, for which we might have one read or two reads, depending on whether we have a singled end or a paired end read. So if we have paired end reads, this means that for each insert we have two reads, and if we have singled end reads, this means that for each insert we have only one read. But it's still a single physical piece of DNA that has been sequenced. So yes, so it would mean the DNA in between the Illumina adapter sequences. So yes, so that is that is what I mean. Yes. So there's the ambiguity. So there is a little bit of ambiguity because sometimes if you say X number of reads, and if you have paired end reads, I think most people would say if you have 1 million paired end reads, so you actually have you actually have 2 million of this little chunks of DNA, and some people, I think that is the most common way of counting, but some people would count twice as large. So it's so in this case we do mean we mean yes. So there was one physical piece of DNA. So but maybe that's a good thing to. I will add a note to what insert means. Okay. Because so actually that's Alright, let's clean this up. Or not not clean this up. Let's commit this. Notes. Okay, so this is done. So first of all, let's mark this as done. Okay, this we do not want to. This we want to commit. So this is in the heat map code. We are removing the code we had written and now just calling the function. And now we are adding this, and the other thing, so you can see here, you see this underscore PyCache underscore. So this is some Python internal stuff. I actually want to get rid of it. Yeah. So also just so again, I'm still sort of learning how this works, but I got this notification that there was a message in the chat, but then it still took another 20 seconds for the message to actually show, for the content of the message to show up, and I was trying to see if I had the wrong where to see it, and then it popped up. Anyway, so where was I? Yes, so we want to ignore the PyCache. So we added to git ignore. So as you can see now, if I do git status, which I have abbreviated by st, then it does not complain it does not complain about the existence of the PyCache. And so I'm going to add ignore that, and okay. And now here I'm going to commit refactor. So the refactor means, so refactoring means when we've changed the code, but we've actually not changed how things work, or we've only changed the internals of the code, but the code's doing exactly the same. So what are we going to say? Yeah. Okay, yeah, so because normally this is a one-two step process, because for code like this, it wouldn't make much sense to just spend a lot of time making it prettier and making it nicer. So, but this is a 1-2. So this was the first two. This was the 1. So we have made the code prettier, because now comes the 2, which is now it becomes a little bit easier to improve it or to add functionality. So that's what we're going to do right now, which is yeah. So this is a common. I mean, for me, 1-2, which is okay. We spend a little bit of time improving things, and then next step is use that improvement to extend the code or to extend the functionality. Right. Okay, so here, so here we have loaded one tool, and so what I'm going to try doing something, which is I am going to just run over a few of the different tools that we have, and just see what things look like. Again, we're still doing a lot of exploring, and so let's just look at all of the tools. All right, so this again, so here we have a list of the tools that we had in this explore.py file, and in the spirit of what we're doing now, I am going to move this into I'm going to move this into load.data.py. you know, we can do something like this. Okay, oh yes. Okay, this would, problem is, you know, if we have already loaded the data, or we had already loaded the load data file previously, and so we cannot. So, okay, so this. Okay. So, okay. Okay, alright, so something failed here. Alright, something failed here. So, not tile, tool, deep ARG. Okay, and deep ARG seems to oh yes, I think we had noticed this. So deep ARG does not have a column called sample, so deep ARG. Okay. Okay, alright, let's open load data again. And so if and tool okay. Okay, and here's the problem is that, so if tool equals deep ARG, at this point the code fails. So there's a couple of things we could do here. So one is, which is what I'm going to do right now, I'm going to special case the deep ARG condition here. So polars change column name. Alright, rename. So there's a rename. Okay. Rename. I don't think in place exists. Okay, so this works, but we only want to do this if the tool equals deep ARG. And let's add this to okay, so we're adding a test for deep ARG. Okay. And actually this is nice because this is a pretty good example of why it makes a lot of sense to have, we're already benefiting from having extracted this load data function because this type of special casing and logic and weird logic, it really does belong in its own function instead of being sprinkled throughout the code. So let's see, and by the way, sorry. By the way, so I added these tests, and this was not, and I just added these functions called test underscore test load data, because this is the format that PyTest and actually a lot of other tools use, but I think PyTest is the one we use, and this allows us to do this, which is, so I ran Python. There's a couple of different ways of doing this, but this is so I'm running the PyTest module, and I think this is optional, but I can tell it which directory. In this case, I want to run it on the directory I'm at, and then it's going to look for things that match this test underscore and then run them. So it ran this test, and for example here, just for, let's say for example there, let's do it this way. It's going to crash, right? Because, or not crash, the test is not a crash, it's a test failure, so the test detects that, yes, so that's the shape is 660 and it does not equal 129. Alright, so let's again, no. Okay, so I'm gonna do two things. So I want to also commit this piece of code, but I want to do it as a separate commit. And I want to do it. Yeah, I want to do a separate commit. So here. I do like to have the history be more or less so that when you do the log, you can more or less see what things were done, and this often means making multiple small commits rather than a single large one. Now I'm also going to what did we? I'm also going to add that we are now using PyTest as well. PyTest. Yeah, PyTest. Sorry. No. Okay. I don't know why we added it afterwards, so let's add it afterwards. Okay. All right. Okay. So we added the. So we added the code. Now let's just check everything. everything loads. So now let's just do one of these heat maps for all of the. Check. While this is running, I'm just checking the chat again. Okay. Okay, I guess RGI. RGI takes a little bit longer than everybody else, or I guess we should have checked this, but that just probably because it has more genes. But okay, just remind everybody what we're doing. So yeah, yeah, you can see it has more genes than everybody else. So not as helpful as that. Hopefully, let's do it again. Okay. Okay, alright, so let's just, okay, this is much better. Alright, so first of all, we can see, okay, some of these tools, 15 genes, 50, 63, and indeed RGI has more genes, which we can see that it takes a lot longer than all of the other tools to run. Alright, let's so I create, let's just run this and output. Oh, I closed it. Okay. Okay. Alright. So now. Alright. So now I'm just gonna. Okay. So now. I don't know why. Something weird happened here with the. Something weird happened here. Oh, I took out the clear, yes. This was yeah, I forgot about this. I thought this was not necessary, but this clears the dendrogram. Okay. Okay, I'm just gonna run this again, and well, this is. Yeah, not okay. Oh, I guess this is still from the previous run. Okay, so so we have about 20 minutes, which is not a. I'm wondering whether to now start looking at the new thing or to wrap this one up. So first of all, I'm going to commit this. So just quick check that nothing was messed up. So by the way, this is not the default on Git. I promised this before. I would show some of these settings, and I will post them to the mailing list. But yeah, but you can. So this is not the default, because here there's so the green means we are adding this line. The red, this sort of dark red, means we are removing this line. So here in this case, clearly we are replacing this top line by this bottom line. We are just removing this line. But then this sort of soft summon means that we are moving this code. So here, and this bluish, so you can see here this code, this dark blue, the code was moved from, so it was moved from here to here. And actually not sure why this is summon and this one is blue, this bold blue, to be honest. It feels like they're the same kind of thing happened. I guess we added this line here. But yeah, you can see that this blue means that this is new code, but code that came from somewhere else, whereas this green is completely new code. So I'm also going to ignore the plots. And I am going to add this code. Yeah. Okay, so what I'm going to do now, going back here. Okay. I'm going to focus again on RGI. I think looking at the data that we saw. Oops, sorry, habitat. Looking at the data, so this is this RGI strip. So this, this is the most. We have 300 genes. So there are some clear patterns, especially as we zoom out. You can see that there's this clear. It's actually, when it's a little bit fuzzy, you see it better. There's this clear pattern. So right now I want to look a little bit into what this is. I actually expect that many of these are not that interesting. That many of these will simply be the TET genes, for example, that they all show up together, where you have the gene and its regulators showing up together, and maybe that's not particularly interesting. But nonetheless, let's look at that. And then next week we can probably try to do this a little bit more formally, right? Because right now I just said, okay, if we see all of the dead genes appearing together, maybe that's not so interesting. But that's because I kind of recognize that if two genes start with the letters D, E, T, that probably means that they are related to each other somehow. But that's not that's not a very formal or very systematic way of approaching things. That's especially because genes have often been named out of historical reasons rather than following very, very logical, strict ideas. Often because we are forced to name things when we see them, and at that moment we actually often don't really know what we're seeing, especially historically, and so things have often been named like it seemed like a good name at the time kind of style. Right, so let's go back. Let's go back. So so we have, for example, let's look at still again, this is not the most formal way we could do things, but there's this. What is this? What are the genes here in this cluster? These are the leaves. Labels. Oh. Yeah. Let's see. This was about to. About here, right? Now the question is, the question in the chat, why does it matter which antibiotic genes co-occur for the so that is a question that we have, is why does it matter? So there's a couple of different ways in which first of all, we actually here are looking at the human gut, so we're looking at mostly commensal organisms, and so actually to the large extent some of these are and most of these are healthy individuals, so to some extent none of this seems to matter health-wise for these people in the very short term at least. What we really worry about with antibiotic resistance is when things come together. So where you have an antibiotic resistance gene that confers a phenotype, or an antibiotic resistance phenotype that somehow finds itself in a nasty pathogen, and those things coming together. Again, if you only have one antibiotic resistance or if you only have resistance to one antibiotic, maybe it still doesn't matter so much because we have multiple antibiotics, but it's when you have more and more multi-drug resistance organisms. And so I'm not sure, actually I'm actually not sure what to expect here. I think there will be at some point we will look into isolate genomes. So far we're looking at genomes, and I think there will be a point where we will basically do a completely different project where we look at isolate genomes. So and my hope is that we can do these two things. So we look at isolate genomes, we look at metagenomes, and at some point these two will converge, and that we'll have congruent results. I think neither really gets at the full picture. Both have severe limitations. So the problem with metagenomics is, first of all, as I was saying, if this really mattered, these are samples from volunteers, and most of them are healthy, or at least not being affected by these organisms. So they are not so bad, but almost by definition. On the other hand, we do get a less biased picture of the world that we have with isolate genomes, and with isolate genomes, you can also see things happening in the same genome. So I'm actually going to be. So this is a question that people often discuss: is what things co occur because they happen. So organisms will carry antibiotic resistant genes anyway, and maybe some of that just happens. If you have a certain taxon often carries a certain antibiotic resistant gene, and that might not be itself problematic. I feel I'm rambling a little bit. But I think generally speaking, we are also trying to understand better when are antibiotic resistant genes really dangerous. So we do know that antibiotic resistance is really dangerous. So we know that. We also know that often antibiotic resistant genes are by themselves not dangerous. We are probably, all of us are surrounded and around us by organisms that carry antibiotic resistant genes, and we are generally, most people most of the time are healthy. But there's things coming together in a bad way. That's when that happens, that's what we want to avoid. So right now I'm still we're still trying to, we're generally, our group, but also I think there's others in the community, are trying to move towards understanding when is it really dangerous and when is it kind of okay. So in that context, we have here these genes. I actually don't necessarily recognize them, to be honest. MC, but one thing, all right, this would be the this would be something to do next week. Actually, is I'm gonna introduce the concept, and then next week we can actually do it. So the concept is, so I don't know. Fortunately, there's nothing here embarrassing, but so we have here. So we have here this list of genes, and these are named by RGI. And this is the list. This is what RGI uses. And just to show you, if instead of RGI I had used DeepARG. This is it. Yeah. So DeepARG uses these names, right? And first thing you can see is that DeepARG uses uppercase, and in this case it's actually not a big deal, because we can probably just compare them. We can just compare them in a case insensitive manner. There's actually much more serious problems, which is that they might use the same, or they might have the same gene under completely different names or not. And so we've been looking at this problem for a while, and Vedant also has a video on it, which is something we've called ArgNorm, where we have taken the arrow, the antibiotic resistance ontology, and then map everything to the arrow ontology. So arrow is, we did not develop this. This comes from the CARD database, the same group that develops RGI, and it has a couple of advantages. So number one is we can, if we have, so right now, we'll have, for example, DeepARG uses this vocabulary and RGI uses a different vocabulary, and so we can at least normalize the same vocabulary. But the second advantage, which is maybe more helpful here, is that arrow comes with, maybe I'm going to show you. Arrow comes, there it is, arrow comes with a lot more information than that. So that's for example, okay, let's look at this. So this is, alright, so for example, this is this first gene in this cluster. Okay, and this is the second one. And so it includes a lot of, and we could do this for all of them, and it includes a lot of information. So okay, so we know. So first of all, there's here some text. So that's nice. That's but there's also here. Okay, this is weird. There's also these relationships. So this is this gene, or which one is ours? Ours is the red one, but it's part of this thing. Let me just do the trees a little bit. And it participates in antibiotic efflux. So we can see that this gene is involved in antibiotic efflux. So that will give us some information about the mechanism, and that's because there's different ways in which these genes can confer antibiotic resistance, and we can do this even more. And here I'm doing this by clicking on text boxes, but this could be automated in code. So that's what we're going to do next week, which is we're going to take ArgNorm, map these things to the antibiotic resistance ontology, and then we'll be able to look at whether, for example, these blocks, whether they correspond to are these all in the same type of gene, or do they confer resistance to the same antibiotic, etc. And I think that would give us a different view into these things. All right, so let's look on time. Okay, we are a little bit over time. Okay, I'm just cleaning up here. Okay, okay, so it's some notes. Okay, so I don't wanna. Okay, generated. All the tools. Oh, genes that anti-co-occur, yes, that would also be really interesting. I think with isolate genomes, we will eventually look into that a bit more. So I think right now we're also just developing some intuitions. And actually you might see behind me that I have a whiteboard where we have this Kanban of as project. So this project really is very initial. Just we're exploring, completely data driven. We really don't have strong hypotheses yet. We're just exploring, looking at the data, and eventually, I hope, we will find something cool. We will develop it into hypotheses, and then test these hypotheses, and and hopefully some of that will be strong enough to be publishable, and we will publish it. But that will be very far in the future, probably months in the future. So that will not be next week or even next month. We can have a big discussion about data-driven versus hypothesis-driven research at some point, but probably much later in the day, not first thing in the morning. Okay, so let's wrap up. Let's stream notes. Yeah, so another question that had shown up last week was why I had at the beginning I mentioned we would use this log branch, and my intention was that if at the end of the stream I had some code that I didn't feel was good enough to commit to the main branch, but somehow still wanted to keep from one week to the other, I would put it in this separate branch. In practice, I've been pretty consistent about cleaning up at the end and always committing. I think the fact that I'm going to be doing that makes me be a little bit more consistent with that, as opposed to my normal practices where I would be leaving things from one session to the next. Okay, document. Okay, with that, I'm gonna push it to the main. I'm gonna play. Yep. And all right, thank you. I will post. I will post next. I will post. So I've said this before. I'll post some of the information on how I set things up because I keep using Git. This Git shortcuts I keep using. I keep using the IPython integration, and I'll post that. I won't do it as on the stream because I'm not sure how many people would be interested in reproducing that, but maybe a few want to just have a look. All right, I will see you all next week. Thank you.